So we are a Women Who Code Python track. Welcome everyone. Good morning, afternoon, and maybe evening for some of you. Our mission is that we are a global nonprofit dedicated to inspire women to excel in technology careers. Our main goal is to empower with the skills needed for professional achievement, educate companies to better promote and retain and hire talented women, build a global community where networking and mentorship is valued, develop roles, and support this generation of engineers. So we are all here about support, about empower each other and help each other in any way we can. Our code of conduct, we are an inclusive community. We are dedicated in provide experience for everyone and anyone who can participate and support this goal. If it doesn't matter the gender, the identity, the expression, anything. The most important thing is that we are here to support each other and to support the goal for the women who code. We have different tracks, just in case you don't know. We have front end, we have blockchain, we have Python, which is us, we have mobile, we have cloud, and data science. I want to thank the sponsors. We have McKinsey Company, Python Software Foundation, the Home Depot, Atlassian. Without them, we wouldn't be here. Also, I want to remind that you can get involved at any time in Women Who Code Python track. You can join as a leadership team. You can be a lead or you can be an evangelist and spread the word. Also help with your technical background and strong leadership skills. So if you're ever interested, you can go to womenwhocode.com/Python, or you can even contact me and I can give you more information. And always join the conversation. We are in all the social media platforms. We are in Twitter, we are in Instagram, LinkedIn, and we are also in Slack. If any one of you is interested to join Slack or is not in there, you can provide me your email address and you can join our community there too. So let me present this great speaker who is coming in today to give us a really nice talk. We appreciate the opportunity that she's coming to provide some of her knowledge and share it with all of you. She's a web developer and she turned a writer unicorn on her dev rel and in her journey. She loves talking about documentation, communities, book, and evolutionary biology. So she's an unicorn, so you can imagine how she's gonna show us today. And her talk is deep learning with Python, long condition classification with CNNs. So let me introduce you to Vishwa. I hope I said it right.
Yes, you did.
Closer. So I'm gonna go ahead and stop sharing my screen so you can get started. Welcome in.
Awesome. Let me share my screen. Thank you so much for the lovely introduction, Liliana. Also, I'm really humbled to be able to have this opportunity to share my experience and learning process with you all. Um, I hope everyone can see my screen. We will get started. Awesome. As Liliana already introduced me, hi everyone. I'm Vishwa, and I you can say that I'm a tiny person with a huge passion for everything technology. I started my journey as a developer a long time ago as a student, and I kind of transitioned from a web developer to a technical writer. Apart from that, I love talking about communities and technical documentation. I love reading books and especially reading about evolutionary biology. So that is something a little about myself. You can find me at the handle mentioned below. That's my Twitter handle. If you want to get in touch anytime, you can just drop a DM. All right, let's get started. So as you can see, the title of my talk is Lung Condition Diagnosis with CNNs. Um, like if you can see the GIF right now, And that's exactly everyone's reaction when we start, like as a beginner, when we start listening to these terms: artificial intelligence, image classification, machine learning, deep learning, CNN. These are huge terms. You can say jargons even, but no one really stops and tries to explain them to you. People have a tendency to just throw around terms like that because these are mainly buzzwords. So I kind of want to clear the thick smoke of confusion here. So for all the beginners, as a beginner, I struggled with understanding what's the difference between artificial intelligence, machine learning, and deep learning. So basically, artificial intelligence, as it is kind of self-explanatory. As you can see, artificial intelligence is an intelligence that is that is replicated by a machine. So much like natural human intelligence, but you kind of train a machine to behave like the human intelligence. A very good example is Alexa and Siri. When you talk about machine learning is a subset of artificial intelligence where you teach the machine to learn on its own and perform certain tasks. You train the machine, and then on the based on the training, it goes on to perform tasks on its own. So it's basically automation. Now, what is the difference between machine learning and deep learning, one might ask? So, for me, basically, the biggest difference is that, again, deep learning is a subset of machine learning, so it's not completely different from machine learning. It just has a few more capabilities. When you talk about machine learning, there are two things called there are two categories of learning: unsupervised learning and supervised learning. So the supervised learning falls in under machine learning, and unsupervised learning falls under deep learning. So that's one difference between machine learning and deep learning. And a very simple way to explain that is that when you train a machine learning model, you have to hard code a lot of training stuff. You have to keep on training the machine again and again. But with deep learning, it has deeper layers. So with every gradual layer, you kind of stop hard coding all the training stuff. You just train the machine once and then it teaches itself. So that's called unsupervised learning. You don't have to do it manually every time with every layer. Moving on to the next slide, story time. So I just want to share a quick story with everyone. As a beginner who was diving deep into the whole data science and artificial intelligence, space, I kind of um, came across a lot of, you can say, gatekeepers. I know it might sound as a very negative term, but that's what it was. It was very demotivating, but I also kind of learned how to grow from it and take it as a challenge. So the story goes like this. I was in my first year of college, and we were going to learn this new course. We all enrolled for this new course for the next semester, which was Python programming. And so I started teaching myself Python on online platforms. So basically, I kind of got to know that Python is great for data science stuff and machine learning stuff. So I went to a mentor. They were basically a professor, but they just weren't teaching me at that time. So I went to them and asked them if there is some platform where I can learn machine learning and data science using Python. And they just looked at me blank in the eye. And after a minute's pause, they were like, I'm not sure if you can start learning that all by yourself because it takes a lot of prerequisite knowledge, and it's not something that you can practice as a beginner. So at first, it was very demotivating for me as a student, as a beginner. And that's why I use the term gatekeeping, because People like that kind of stop you from learning and exploring on your own, which is not very difficult if you ask me. So, this was a lesson for me, and I took it as a challenge. I kept on exploring the online platforms and free resources like Kaggle and Analytics Vidya, and taught myself basic data science stuff. So at least I knew enough to get started. So this is my message for all the beginners and the newbies. Please do not get demotivated by stuff like that. People are always going to throw jargon at you, and they're always going to tell you that you cannot do something because you don't know enough. But the trick is not to get demoralized by it, but take it as a challenge, just like I did. So let's move on to the actual stuff. In my last year of my BTech degree, which was in computer science, I just graduated, by the way. So Respiratory Body was a project based on deep learning using CNN that my friends and I created for our final year project. So, what Respiratory Buddy is that it's a deep learning model which classifies chest x ray images to diagnose 14 distinct lung conditions, like lung diseases, using a convolutional neural network. Now, I know that it might be a bit overwhelming to hear a lot of stuff like classification, CXR images, convolutional neural networks, but gradually into as we move on, I will explain all of it. All you need to know right now is Respiratory Buddy is kind of this web app. It is a website. You can say that we a web app that we built in Flask. You just upload an image of a chest X-ray, and what it does is you just click a button, and what it does is it diagnoses the chest x-ray for 14 different lung diseases. It kind of tells you, hey, you have pneumonia and this is the percentage that you have in your lungs. All right, moving forward. Okay, so yeah, as you can see in the GIF, this is basically me when I get frustrated because there are some hard truths about machine learning that I would like to share with everyone. The first is something that I already discussed: gatekeeping. People trying to tell you you cannot teach yourself stuff because it's too difficult and you're not qualified enough for it. Second is a bit technical. Um, when you're practicing machine learning, it means that you have to train the machine learning model, you have to train your machine, and for that you need data. And you know how expensive data is because it's a very precious resource. So for training huge machine learning models, you need even huger data sets. And not a lot of data sets are open for you to practice upon. So that is the first hurdle, first hard truth that you kind of realize when you get started with machine learning. You might not always find the suitable data set that you want to train your model. Next is you need a lot of processing power, processing capacity. And by that, I mean when you're training your model, it's going to take a lot of CPU power. To be specific, it's going to take a lot of GPU power, GPU capacity. We don't use CPUs for data science. So not everyone can afford that. Not everyone has access to that. So people like beginners, beginners like me and you, people who do not have a lot of resources, a lot of access to expensive stuff like that, kind of find it very difficult to get started with machine learning. So even I faced this problem when I first started practicing data science and machine learning. I in my when we started working on our final year project, there was this term that a professor explained us about, and it was completely new to us, and we instantly realized that this was the solution to all our problems. This was the solution, the sweet truth to all the hard truths about machine learning. Let's see what it is. Transfer learning. So when the professor explained us about transfer learning, It was the first time we were hearing something like that. It had been almost 2 years that I had been practicing machine learning and data science in general, but I had never come across a term like that. So, what exactly is transfer learning? It is the solution to all our problems that we face as machine learning practitioners. Transfer learning is this concept of pre training or fine tuning an existing machine learning model. So, what you do is, since you don't have access to a lot of open, huge data sets and a lot of computational power, all you have to do is pick up an existing model that is out there. A lot of open source models are out there. You have to pick that model, fine tune it according to your specific use case. Fine tuning means you probably add a few layers if it is a deep learning model, or you just change the classification that you're doing. If the existing model classifies the images of dogs and cats, you probably classify the image of particular dog breeds like Labradors and German Shepherds, let's say. So that's what it does. Transfer learning reduces the computational power needed for training a model because there is an existing model which you only have to add layers to or change the classification part. In any machine learning training process, it can be divided into two particular parts, which is the classification part and the feature extraction part. So what you do first is feature extraction. You kind of define some classes that you want to categorize your data set into. Let's say if you're working with image classification and you're using a data set, so what the feature extraction part does is all the classes that you defined, let's say cats, dogs, pencil, watch, etc., it is going to extract all the features of the images present in the data set. Let's say there are 1,000 images in the data set. The feature extraction part is going to extract all the particular traits and characteristics present in each and every image. So, based on the feature extraction part, the machine can then go on to train itself to identify the images and classify them into categories further on. So the next step is classification itself. As I said, after the feature extraction, the machine trains itself to learn how to identify those classes and classify the images based on that. So let's say if you upload an image of a watch, the machine, based on the feature extraction, is going to identify if in the feature extraction process it taught itself that if an image has two hands, it has numbers from, let's say, 1 to 12, it has a round dial. These are the features that it extracted, and based on that, it's going to classify that image. So these are the two main parts that a machine learning training process involves. So in transfer learning, you only pick up a model, you use the pre-existing feature extraction, and you fine-tune the classification part. Only the classification part. So that saves a lot of processing power, and it also does not need a huge data set for you to train the model. I hope I'm not going too fast and my pace is good and comfortable for everyone. I can repeat stuff when you ask questions, any questions that you have. Moving on. This is the specific. This part will be specific to my project. These are the building blocks. All the parts in the architecture of our web app that we build are explained here. So first is dataset. As I said, our project is a web app, a platform where you upload an image of a chest X-ray, and it's going to tell you what kind of disease you have based on your chest X-ray, and how much percentage of or how much probability you have of having that disease in your chest. So for that, we needed to train a model. And based on that model, the deep learning, our deep learning model was going to classify. So for the classification part, we used a data set for the training part, we used a data set called Chest X-ray 14. It had 1,000 different classes. Classes mean categories. For example, in general, watch, pen, pen stand, cup, um, car, books, cats, dogs. These are all classes based on which a model is going to identify what kind of image it is in image classification. So this data had 1,000 classes based on lung conditions. And it was made up, it consists of more than 10, it consists of more than 100,000 frontal view chest x-ray images. It is a huge data set, and we were fortunate enough to find it open source, which means it was open for us to use. We could use it free of cost. Next up is the model. Now, the model was the main part, the essence of our project. Now, as I said, we used the concept of transfer learning in our model because we wanted to reduce the computational power, right? So what we did is we found this really nice existing deep learning model on the internet called the Inception V3 model. Now, the Inception V3 model is a very widely used and widely popular image classification model that is open source. So you can just install it. You can just download it, and it has already been designed and developed by multiple researchers over the years. So you don't really have to hard code a lot of stuff. Um, it is already pre-built, and you only have to get it and fine tune it according to your particular use case. So for to give some more insights into the Inception V3 model, if anyone has heard about the very huge open source data set called ImageNet dataset, you might know that it is a data set of all kinds of images that we find of objects into our world, right? Anything that you can imagine, its image is in that data set. It's called the ImageNet dataset and it's open source. So this Inception V3 model is actually trained based on the ImageNet dataset. So you can imagine with that sort of huge dataset, the accuracy of the Inception V3 model is already high. It's almost more than 78%, which is a great number to start with. So all we had to do was take the Inception V3 model, and it has a very generalized set of categories. You can upload any image that you find, and it's going to turn up with a result of what image it identifies as. So now what we had to do was, instead of, let's say, uploading images of cats and dogs and the model telling you, okay, this is a cat, okay, this is a dog. Instead of that, we wanted it to tell that this particular chest x-ray that you've uploaded has pneumonia, or it has cardiomegaly, stuff like that, right? So that means that we had to fine tune it. Now, fine tuning means the pre training of the classification part. So, for that, we use the chest x ray 14 dataset, and we pre trained our model based on the Inception V3 model. Next is we had to embed the model that we trained in a front end. We had to create a front end for people to come and for people to visit like a URL and upload the chest X-ray image. So we created the front end. It is a typical concoction in the life of a front end developer. As everyone knows, basic HTML, CSS, and JavaScript is something that you can used to develop a nice website or web app. So that's what we used for our front end. Now the backend, for the backend, we used a framework called Flask. It is a very lightweight web application framework based on Python programming language. So So if you're a Python developer and you want to create a web app, the backend that you can use is Flask. Now, the reason why I love Flask and the prime reason why we picked Flask is that I find it very flexible. A lot of the frameworks are going to tell you that you have to install 10 dependencies or you have to install 15 packages, and those are the exact packages that you can use to build a web app in our framework. But Flask does not do that. You can choose your own tech stack. The only constraint is that the programming language that you're going to use will be Python. But I don't find it very restricting because Python is an amazing language. It's very flexible, it's very beginner friendly, and that's why I love using Flask. It's very flexible. It does not tell you that these are the exact packages or frameworks, technologies that you have to use. It can let you choose the libraries that you want to use for your backend. All right. So I've talked about a lot of theory stuff, and I know everyone here wants to see some of the code. So I'll show you a quick demo of the web app that we built. Just a minute. I'm sharing the screen with everyone. All right. So let me first run it and show how it looks on the front end, and then we can come back to the source code. So this is basically my VS Code editor, and you can see this is the project directory. There is a README file for all of you to refer. Liliana will later on share the link to the source code. This is the Inception v3 model that we fine-tuned in IPyNB. That is a library that you use for Python image classification stuff. Then there's this requirements.txt file. So what you basically have to do is run this particular command, pip install requirements.txt. What it does is all the dependencies that you might need for this project to run locally on your machine, it's going to download and install all of that. And yeah, so then you can get started by firing up the server. Let me quickly do that. The command for that is python 3 server.py. Now server.py is the script that we wrote for this web app. I click enter and it's going to fire up the production build using TensorFlow backend. TensorFlow is the framework that we use for the machine learning stuff. Okay. Just a minute, I have to share the window again. Okay, yeah. So this is the front end. Respiratory condition diagnosis made easy. Respiratory Body AI for good. So you just click on diagnose. It's going to take you to this page where you can choose the file that you want to upload. I have this X-ray image ready, x-ray.jpg. I'm going to open it. So you can see that the file has been uploaded here. You just click go and it's going to classify. So right now, the model is working. It's scanning the image and classifying it in all those categories. 14 lung conditions that we mentioned. It takes around 45 seconds to a minute. It also kind of depends on your internet speed. If your internet is slow, it might take longer. Yes. So as you can see here, there is a class name. So these are all the diseases that we have defined in our model. So in our model, there are 14 classes. So whenever we upload a chest X-ray image, it's going to classify the image, the probability of the lung condition into these particular 14 different classes. And then besides that, it's going to turn up with the score of the lung condition. Now the score means the probability of the chest X-ray or the image having that particular disease. Yeah. So let's get back to the source code. Let me share my source code with you again. All right. So this is the chest X-ray image. Going back to the server.py Python script. Yeah. So this part is where I've imported all the libraries and packages that we needed for this web app to run. There are a lot of methods that we need for it. So basically, this part is where we import all the packages and methods, right? That we'll be using later on in the web app. These are the classes. So as you can see here on the front end, as you saw, there were 14 different classes. So this is the part where we defined those classes. That's where it came from. Those classes are the diseases that we classify the image based on. Now, this is the Flask app that we built. This here, the app building starts. And then there are 4 different, you can say, methods or functions. So as you can, mostly methods. So there are 4 very important methods in this app. The first one is preprocess image. So what it does is when immediately when you upload the image, it's going to pre-process it. What it means is for the machine to understand and classify that image, the image has to be in a certain format. It has to be in a suitable format for it to scan, right? So the pre-processing image method, what it does is it takes the image and it pre-processes it. It resizes, changes the color to grayscale and stuff like that. It divides, subtracts, multiply. That is actually the resolution. So it filters a lot of stuff. So you can call these as filters. The next two methods are actually load image from URL and load image from system. So these are the two methods that we created for the convenience of the users. The users can either upload an image from their local machine, or they can get a URL from the internet and paste it in the search bar and use that URL for the image. The last one is the predict method. This predict method comes from the model. So what this method does is, as you can see here, model.h5, which is the model that we fine-tuned here, as you can see in the directory. It is encoded, so you cannot see it the whole file here. But yeah, so that's where the data comes from in the predict method. Everything that we train the model to do, all the tasks, that's going to be bundled up here, and all those tasks or the functions are going to be called here in this method. And then based on the classification, the image classification, it's going to return results. Yeah, so these are the app routes: classify system, classify URL. These are the routes. These basically, these are methods, get methods. So what it does is, whenever, if you can see this classify image, classify system, what it does is, when you click on that, on upload image or choose image, what it does is it lets you upload an image. It fetches it from your system directory, and then it puts it on the front end. So these are the routes. Yeah, and this is our main function. And this whole thing was our Flask web app. So that's basically the server.py script. So this is our main script. And these are the two main models: the inception fine-tuned model, and based on that, our final model.h5. Yeah, everyone. So that's basically my project and the source code, and that's the conclusion of my talk. And we can now begin with any questions that you people have. I hope I was able to provide some value and some insights to machine learning and image classification using deep learning and CNNs. I'm going to stop sharing my screen and we can get on with the question and answers. Thank you, everyone.
Thank you very much. That was really, really interesting.
Thank you.
And thank you everyone for being there for us. If you guys have any questions, you can write them down in the chat or you can talk as well.
Hi Tanay. So we kind of tried hosting the code online on GitHub, but since GitHub has these restrictions, these site it you cannot upload a certain file size on GitHub if it exceeds their limit. So what we did is the final source code that I have running on my local machine, I uploaded it. I compressed it in a zip file and uploaded it on my drive, and I've shared the drive link with Liliana. So I'm sure Liliana can share it with you all later for everyone to check it out.
Yeah, I can. I'm gonna be able to put it in our Women Who Code Drive. So and then I can share it later. If some of you, I can share it in Slack, which is easier for people later. So if you are not in Slack, make sure you send me your email and I'll add you there so I can share that link a little later today, just to make sure everyone who wants to see the code can go ahead and see it from there. Any other questions?
Yeah, sure. So REST API, let me think where I started. I think it was second year in my college when I started practicing creating a REST API. There's this platform called Postman, if you've heard of it. So what it does is it lets you create REST APIs from your own custom REST APIs from scratch. I think you can check that out. But apart from that, there's always platforms like Hacker Earth and stuff like that that teaches you things about REST APIs and APIs in general. If you can check that out, a very good platform. I know it's not very specific, but a very good platform is dev.to, the blog. So it's a very huge community, and people who are practicing stuff, they write about their learning journey and they share their blogs. So that's you can check the dev.to blog platform, and I'm sure you can find relating blogs based on REST APIs if you can just search it. Yeah. Yes. Hi, Julie. That's a very interesting question. Yeah. So we actually are working on adding more classes to the model in the future. It's going to be a bit tricky because the more classes that you add, it's going to need a larger data set, because that means that you have to fine tune the model again, you have to train the model again, and for that, for any model to be more specific and have more classes, it's always going to need a larger data set. So yes, we have that in our future scope. We are planning to add more classifications. Right now, it's a limitation that our deep learning model, only classifies the lung conditions and only 14 lung conditions. So that are the two of the main limitations. But we're trying to remove those limitations. We're going to move on to add more classes to the lung conditions and make various models like these for other diseases, not just respiratory diseases, but other diseases. Let's say MRI scans. So that means we can also diagnose the brain. So there can be a preliminary diagnosis because MRI or CT scans can be very expensive. So if that can happen, it's going to be very useful. I hope that answers your question.
Can you elaborate? Oh, okay. I was wondering, when you want to add more, do you have to start all over again in ML?
Sorry. Hey Tatian. It was lovely to have you here. I really hope I was able to provide some value to everyone. We'll see you later. Thank you for being here. Moving on to Arzu's question. Can you elaborate on the use case of transfer learning? I'm not sure what exactly you're trying to ask. Can you elaborate your question more? And I can move back to it. Okay, Julie's question. I was wondering, when you want to add more, do you have to start all over again in ML? No, we don't have to start over. As I said, I hope this also answers Arzu's question. We don't. That is the purpose of using transfer learning as the concept in machine learning. Whenever you're trying to broaden your use case, or let's say trying to scale up your model, you don't have to start from scratch back again. All you have to do is fine tune the model, use a larger data set, and add more classes to it so that it can identify more images, more types of lung conditions. Okay, in your demo, you use TensorFlow, but what do you think of using PyTorch to apply deep learning? Yes, we did, research a lot on that. If we wanted to use PyTorch or we wanted to use TensorFlow for deep learning, I think it really depends on your use case. PyTorch is also a good option, but a lot of the libraries and technologies that we used went really well with Keras and TensorFlow, because for me, choosing a technology is not just about the technical stuff. It's also about how convenient it is to find the resources readily. And we just used TensorFlow because it has a huge community and a more transparent community. So we kind of were able to find resources more readily if we went on to use TensorFlow. If we wanted to use PyTorch, it was very frustrating because, first of all, we did not know where to start. We did not get a lot of reference material. So, since it was a research based project, we wanted to make sure that we have enough resources. So, that's why we use TensorFlow. Okay, moving on to Arzu's question, where and why do we exactly use transfer learning? Yes, that is a very interesting question. So, when I recommend for everyone who has a smaller project in machine learning to use transfer learning, because it is possible for people with small projects to train a model from scratch. But as I said, it's going to take a very huge data set, which means it's going to take up a lot of space, and you will probably need a lot of processing capacity, processing power. So if your use case is very small, like ours, it was only a small project that we kind of completed in the course of 6 months, including all the research part. So that's not a very huge project. So if the scope of your project or your use case is really small and you don't have access to a lot of resources, you don't want to pay for data sets and stuff like that, you don't want to pay for processing power, transfer learning is a very good option for you, because it means that there are pre-existing resources and models that you can use and you can just fine tune it. I hope that answers your question, Arzu.
Any other questions?
I would love to answer your questions. If you don't have any questions right now, I hope you all took a note of my Twitter handle. You can always drop a DM there, and you can ask questions later on too. I'm always up for it. Where and why do you exactly use transfer learning? Can you also talk about how small a project should be? I don't think there is a constraint on using transfer learning. So it's not like you can use transfer learning only if a project is of a particular size, or like if it's small enough. It's just more about what kind of resources are available to you. So if you have a small project and you don't want to um, train a model from scratch, then you should use transfer learning. Apart from that, I think you can always have this choice of training the model from scratch, even if your project is small, because that means if you're a beginner and you want to dive deep and practice all of your machine learning stuff and like statistical and numerical analysis and stuff like that, practice on notebooks, you can always choose to not use a pre-existing model and make one yourself. But we chose this one because we had very limited time. It was for our project, our college final year project, which meant we had to publish papers, we had to write review, literature review, we had to make presentations. So creating or developing the web app and the model was not the only task. We had a lot. So we thought it would be really convenient for us to use an existing model and just fine tune it for our use case. So there is no constraint on a size of a project. It's just about your preferences. If you want to learn how to train a model from scratch, or you just want an easier or a more convenient option. So in the latter case, you can always use transfer learning. So Julie's question is, will this project be available all around the world? For example, in France, can I recommend this to a doctor? Yes. So yeah, you're welcome, Arzu. Okay, getting back to Julie. So right now, it's in a very beta stage, as you can tell, because we kind of worked on this as students. We haven't patented it yet, so it's not legally our product yet, but we are planning to do that in the near future. It might take a year or closer to that, because everyone, like my team, it consists of four members, myself and three of my other friends. So we're all around. Everyone is in a different place right now, and we have our jobs. Other people are looking for jobs. Some people are doing a master's degree. So it's going to take a time to patent it and like move from the beta stage to a very updated version for people to use it all around the world. But yes, it is definitely our vision. The main vision or the goal was to create this web application so that it reduces the time. It's very cumbersome to go to the hospital every time and get like a radiologist appointment, because not every radiologist is it takes very qualified radiologists to do this procedure, and sometimes you might not find an appointment readily. So this web application ensures that the medical personnel can carry out the preliminary diagnosis with ease, and the patients don't have to wait on the results for a very long time. So if we patent this as our product, you can definitely recommend this to a doctor. I'm not sure when we're going to be able to complete this, but in the near future, we'll definitely do this. Yes, it's a beautiful community. Everyone is very supportive, and I have recently joined the community myself, and I'm really glad that I did that. Because you can always, if you're in the Slack channel, you can always come talk about something that you're working on. If you need any help, you can ask anyone, and maybe they can connect you to the person who knows about it, or if they know about it themselves, they're going to help you out with that. So mentorship is one thing. Collective growth is another thing that I love about communities, and you always find this as a very comfortable space. So if that is something that you want, also there's the job prospect of it. Women Who Code is a beautiful community. They always put out good resources. They connected you to recruiters, companies that you can potentially join. So yes, that's something that I love about the community. And if you're in the Slack channel, make sure you always talk to people and be interactive. it's always very beneficial.
Also remember that this community is to help each other, and you can ask questions. We have different channels anytime we have, and someone will go ahead and reply for you, and we are here to support each other and to help each other to grow. Okay, so we are gonna go ahead and conclude this. Thank you everyone again. Thank you, Vishwa, to give this amazing talk. We appreciate your time. It was wonderful. And I hope everyone has a good day.